All right, so our next presentation, the one that everyone's eagerly awaiting to get a free graphics card at as well. We have NVIDIA is here to talk to us a little bit about MassFX and some of the physics stuff that's coming out of NVIDIA that we've been putting into 3ds Max, as well as some of it starting to show up in Maya and a few other places. Really what you'll find is we have a very strong partner relationship with NVIDIA. We share a lot of technology back and forth. Things like the mental images technology, all of that stuff it's really a constant back and forth feedback process. So at this point, I'd like to hand it off to you guys, and feel free to take it away.
Thank you. My name is Daniel Horwitz. I'm the engineering manager for DevTools Physics at NVIDIA, and this is Eddie Johnston. He'll be talking a little later about mCloth, and he's from Size 8. Okay, so quick overview. We're going to talk about the design principles for these plugins and for MassFX, and then discuss how the NVIDIA PhysX plugins and MassFX are related. We'll go through a few simple videos, talk about upcoming releases, and get a preview of partner integrator plugins. All right, lots of words up here, but I'll walk you through it. So the NVIDIA PhysX plugins are released with each new version of Physics and Apex, and this is 2 to 3 times a year. It has the most cutting-edge features, usually for new things that are being introduced with the newest versions of Apex and Physics, but we do tend in those releases to prioritize on content creation for external GPU-accelerated applications and not necessarily having quite everything for movies and films at that first release stage. This is also limited to registered developers from the NVIDIA website. Whereas the Autodesk MassFX is on a yearly cycle, and it branches from our latest co-development tree. And with that, depending on when it branches off and what the lockdown dates are, it might be released. We may have removed a few features due to the necessity to lock down for translation, so that we can hit more markets. Along with that, the UI designers have a second chance to work more and polish on the GUI to make it yet a better and deeper experience for this crowd. Along with that, we tend to add a few extra movie-centric features and remove some of the features that might be deemed a little too game or GPU app or simulation-centric. And there's a bidirectional push, of course, through the process between the 2 versions of these plugins. So feedback is welcome, I'm sure, to either company if there's a feature that you might need in one version or the other that might not be there. All right, so our design principles. Physics upgrades graphics. We really want to fit the natural flow of your content creation studio. And that usually means that you're developing the graphics first and the animation first, and then you want to add physics to that. So you wouldn't want to have to take your rigs and break them all the way down and rebuild them just to put the physics onto that. So we're trying really to amplify the authoring, to let you do more with fewer clicks, be less disruptive to content that you may have already created, give you higher level objects to work with, to multi-edit, and to manage a massive amount of objects in your scene. Along with that, WYSIWYG, what you see is what you get. We want you to be able to simulate right there in your viewport and get the same experience that you're going to be able to get with any offline application, because hopefully you're using the same exact runtime. And this really avoids the tedious guess and export loop where you might write in a magic number, have an export and serialize the disk, and then load in this external application again in order to check your work. And that's maybe taken a minute of your time, and then you have to do that 100 times in a day, and all of a sudden you've lost hours of your day that you wish you could have had back. And of course, if you simply get more time, you can work on either making it higher quality or just get the job done faster. So here's a list of our existing features. The clothing isn't actually in the 2012 version of MassFX, but it is in the NVIDIA plugin. We have the rigid bodies, and multiple shapes can be set up on those and constraining them together. And then ragdolls can help you manage all of those together. So rather than going into too much more detail, why don't I just do a demo? This is the Global Tegra 3 demo running inside of Maya interactively. So I'm going to actually be using hotkeys here to manipulate the scene. Performance is a little slower because I'm running on a laptop, but we have integrated scripts that can be triggered during every frame. As I approach these boxes, the jack-in-the-box is going to pop out. Some of them are hammers. Some of them are fists that can throw me quite far around the scene. Of course, this is a little hard to do perfectly each time because it's unique every time. Oh, there we go. We're getting tossed around. Performance, well, it's slow on this laptop, but it can actually be pretty good on a normal desktop. And a lot of that's actually due to this cloth. We haven't turned off the normals. Some optimizations will come later, but with all the extra work to recompute the normals, and we have about 7,000 simulating cloth vertices here, so it's quite a bit. So here's the orange is just showing you the rigid bodies in the scene. Some are simple boxes, some are convex holes. And something else interesting you may have noticed was as I was simulating, the ball doesn't actually stay in the center of the scene. I have this extra layer for our camera where our camera's point and aim constraints are actually set up to be working with a physics rig. So as the scene is tilting, the focus point will move around, or even as objects hit, as the jack-in-the-boxes hit the ball, they'll also bounce around. So even here you can notice, right, that the camera bounces to some extent along with the system. All right, Apex clothing. This is a hybrid of simulation and skinning to deform the graphical mesh. So you get to use your animation and your and the simulation to hybrid the two and make a better result. We have per vertex painting where you get to put the constraint values on there. The biggest one, of course, being the maximum distance. That's the most important, is how far the simulation is allowed to stray from where you animated the clothing to go. Latch to nearest is that one actually allows you to do thick clothing. So rather than having to make everything paper thin one polygon, you can model it where it's two planes that are separated apart, and you can paint the regions separately, and they'll snap together and simulate as one region instead of two. We also do support soft bodies, but this is a more accurate and quicker solution, right, to treat your cloth as a flat piece when possible. There's also several level of detail features that I won't delve in too much further here unless we have time at the end. So here's a few videos. Some of you may have seen this. It was released at GDC. It's the Epic Samaritan demo. So this character, you can see all the buckles and the belt all hanging down and colliding against the legs and the objects in the scene. There's some great secondary motion, also, which is more subtle though, around the cuffs of the character's hands. So they're never quite always in the center. Along with that, there's some good motion on the collar. But down the back and the chest, it's all very tight and close to the character, so that you get the proper look and feel that you're hoping for, and you can also prevent mishaps that might happen in a more interactive simulation, such as the coat coming over the top of the guy's head. You can completely control that and prevent those things from happening. We wanted to show that this can be applied not only to a trench coat and a dress. Instead, it can add some really great secondary motion on a simple character walking around. Cut a little of this out. All right, you see a lot of motion as he jumps up and down also. and through the chest area and around the legs, wrinkling and everything. This is another one that I guess is complexity-wise somewhere in between the amount of motion on the full trench coat and the guy just in a shirt, right? Lots of great secondary motion. At the bottom, his tie is also simulated as a piece of cloth. And in this one, actually, we're using the backstop, which is a approximation of the skin geometry. So rather than colliding against a lot of rigid bodies, you can actually collide against this representation, and you get faster results, and in some cases, even improved. Here's a sped up video of the authoring. I wanted to do this live, but 30 minutes and a bunch of videos, it's hard to squeeze it all in. So here he's isolating the clothing so he can paint on it, applying our modifier, and switching to the paint mode. So you'll see everything turns up magenta at first. That means there's no motion allowed. And then he's going to start drawing the gradients for the maximum distance. These noodles that you see here, those are visualizers to show you actually physically how far those vertices could have moved. He turns it off, though, because he prefers just to look at the coloring that he produces. And we have a black to white range, and that range can even be mapped if you want to concentrate on really small detail in a specific range of motion, in which case we'll show you also with additional colors which are above and beyond that range. So once he's done drawing on these bands of thick gradients, he'll switch into the smoothing mode and then run smooth a couple of steps, and we have an additional checkbox on there where it can ignore smoothing into that, that restricted magenta area. So now he has a perfect gradient, and he can simulate immediately right there while painting. Now he's going to set up the ragdoll. First, isolate the skinned character, and then apply the ragdoll helper. And then you add the bones that you're interested in to the ragdoll helper, just like a skinned object. And this will allow us, in one big step, to generate all the rigid bodies on the bones that you're interested in. In this case, he only does the lower body, because that's really where all the motion of his cape is limited to. And it defaults to capsules, but it could also be more tightly fit auto-generated convex holes. And that's also taking apart the mesh based off of bone influence weights. So this is the final result that he's rendering here. Or actually, this is not rendering. This is actually live in the viewport, or at least when he produced it. So you don't have to render it out. But we do have baking features so that if you want to finish the simulation and then piece it into something else, into a movie, you can do that. I have the same thing here. So first you see the clothing releasing out of that initial pose, and then it drapes nicely and collides against the guy's legs. I have them locked in place just to make it nice and simple. Okay, Apex Destruction. This is a great new feature that's coming, but this is very early preview and won't be in until a much later release. It might make it into MassFX, but we don't know yet for the next version whether or not it'll be in, so no guarantees there. So the basic idea here is that we're applying behavior to a fractured mesh. We're going to let you manage, we manage the hierarchy in chunks and how it's going to break down into smaller and smaller pieces and potentially even crumble into dust, which is an optional feature, the crumbling. We're also going to have a pluggable fracture stage, so we're going to provide a default fracture for you, but you can fracture it yourself, handmade, and clump them back together. And we're also going to support third-party plugins to this system. Once you've fractured it, you can preview the individual levels, spread them out, and you can even go to individual chunks if you don't like what maybe a auto fracture did for you, and tweak the geometry yourself, both the graphics and the collision. So I could demo that one really quick here for you. Nothing too complex, like I said, since this is only a really early alpha. Wouldn't even really call it that. It's only been running for about 3 days. We'll give a second for the progress bar to finish as it slices and dices this teapot. And there you have it. The teapot hits the ground and slides apart into pieces. Well, we don't have any of these set up yet to determine how it's going to break apart as far as how much force is there, but all of those parts of the GUI will be there eventually. Okay, for our releases, we're currently at 2.6 or MassFX 2012. This is the versions of PhysX and Apex there, 1.0 and 2.8.4. Our next release for the NVIDIA version will be coming out in just a few weeks, and that's going to introduce PhysX 3.1 and Apex 1.1. I already mentioned these clothing enhancements. We're also going to introduce contact layers into the Maya system, and this is really collision filtering, like that camera rig that you saw there. It was in its own collision layer so that those boxing gloves couldn't hit the camera rig and make the ball go flying also. And then the release after that will have destruction, soft bodies, and contact layers inside of 3D Studio Max. We also have opened it up to work with some partners. And first up is Particle Flow. So that first scene, the teapot is MassFX, but it wasn't colliding. So now he's going to switch to a MassFX scene. And as you can see, it starts to collide against that. And then he's going to amplify the amount of geometry that he has, making the boxes smaller, more dense, and a larger grid. You can see it quite nicely handles a ridiculous number of boxes. So he can switch the geometry to spheres, and that's not just not just still using boxes. It will actually switch the primitives along with that. He has a glue system where these can all be tied together and act more like a soft body. And this next one's my favorite. We have a simple little clothing trampoline. It's going up and down, and the particles are just flowing into it, and it's holding it up and bouncing them up and around and spilling them out everywhere. It's simple and fun. But definitely shows that the systems interact quite nicely. All right, next up is MCloth. Here you go, Eddie.
Okay. You play this for me? So the idea here is that Apex clothing is more designed for doing clothing on your characters, whereas there is many occasions where you want some general purpose interaction between cloth and other collision objects. So you want dynamic interaction between some spheres and a piece of cloth which we might want to make into, say, a trampoline. So the idea is to make it a little similar to the previous cloth plugin. So you've got the various constraints and groups that you can animate and various parameters for turn them on and off over the time. Here we're creating two different groups. One of them is turning on and one of them is turning off at a certain point to make this corner loose halfway through the simulation. The idea is also that things will simulate a lot faster. You can iterate your parameters a lot more quickly. So here we're turning the spheres into dynamic objects, and the cloth has had the mCloth modifier applied to it, and the other constraint comes loose at a certain point through the animation. all the parameters that are available in physics have been exposed in this plugin. And another example that will come up next is if you don't want to do some clothing, but you don't want to mess with all of the complicated backstop and maximum distance, and you want to do something a little more similar to the previous cloth plugin, you can simply apply the mcloth modifier to your cloth mesh. And here we use the ragdoll application to create a ragdoll out of a skinned mesh. You can see here it creates collision spheres, but then you can change that to a convex hull. And then once you've applied the cloth modifier to your cloth object, then you can adjust various parameters, the thickness, the number of solver iterations to get the behavior that you're interested in. Then press simulate, and it simulates very fast. And then you can go ahead and modify your collision offsets and to get the particular behavior that you want. So this is simulating real time. There's about 4,000 vertices in this cloth. And then everything is cached out as before with the previous cloth modifier. So you can import and export your caches and do the same kind of things as you could before. So that will be coming in very soon.
Great, that's it.
Yeah, that's it.
Thank you, Eddie.
Meeting.
All right, thank you very much, guys. Excellent job.